Okay, so we'll do two examples in this video also to try and keep it short, but not inundate you with numerous videos in the whole section. So as I'm looking at this, I say, okay, what am I going to do with this? One of the first things that, Mr. Thornley's telling you to do is get things in terms of sine and cosine. Well, it's already in terms of sine, right? Look for squares. Okay, there's no squares, so the Pythagorean identities right now aren't going to work. This guy is not a Pythagorean identity because I have sine squared theta plus cosine squared theta is equal to 1. These guys don't have a square. Okay. But what if I had like 2 minus x, I don't know why I used a 2 because there's a 1 there, and 1 plus x. Could you multiply those guys together? Sure can. So I'm going to go ahead and multiply these two guys together just using distribution. And so as I go through this, you should notice that it's a difference of 2 squares. These guys are conjugates. So what happens with conjugates is, sorry, a little cough here. So what happens with conjugates is the middle term cancels out. So I just got to multiply my 1's together. Negative times a positive is negative, and multiply the signs together, which gives me sine squared x. Now I am seeing that square, and I should be thinking to myself, I need to use this Pythagorean identity. We just saw in the last one, if I take sine and move it to the other side, I get 1 minus sine squared. That's going to equal cosine squared. So this whole guy right here is equal to cosine squared theta. Okay? Okay, so we're going to prove that this left side is equal to the right side. So a little bit of proof here. It's still a trig identity, and basically this is nice because I know it's going to equal 1. It's not like a geometric proof where you have to write out all these steps. We just need to work with these. So there's a couple different ways that I can work with this. I see the tangent squared. Some of you might think distribute the cosine. We could do that also, which might not be a bad idea. But the first thing that I'm going to do is I'm going to write down my Pythagorean identity, and I'm going to see what I get. Okay? So 1 plus tangent squared is equal to secant squared, so I could just take this guy and plug it in. And if I know that right off the bat, I just plug secant squared in here, know it's being multiplied by cosine squared theta. It's supposed to equal 1. I then show that, well, that's secant squared, right? And that's cosine squared. And I got the same thing over the same thing. So 1 is equal to 1. Boom. My proof is done. Okay? So the idea here is you need to remember that because it makes this problem easier. I'm going to do it a different way. Okay? So what if I didn't recognize that this was a Pythagorean relationship? I can go ahead and distribute. Let's see what happens here. So I'd get cosine squared plus tangent squared theta times cosine squared theta. Okay? So now I'm going to go ahead and I'm going to replace tangent with its identity, which is sine squared over cosine squared. Okay? Not bad, right? Okay, not too bad. I see that this guy right here is cosine over, well, hey, I got a cosine and a cosine, and that would leave me with cosine squared theta plus sine squared theta. And what does this guy equal? 1. We still end up with our Pythagorean identity or a Pythagorean relationship, whatever you want to call it. But this one is probably the most remembered one of all. So there is more than one way to do these types of problems.